welcome. Nakuzionyeka, you're welcome. Thank you so much for coming. All right, so let's give them a few minutes so that we can proceed from where we stopped yesterday. Hello, everyone. Good afternoon. Welcome to today's class. Now, we are going to proceed from where we stopped. Yesterday, we did linear expansivity. That is when an object expands or increase only by the length. But if the increase or the expansion is done by the length and its breadth, it is classified as area expansivity. And also, if it is increased by the length, breadth, and height, it is classified to be volume expansivity. Yesterday we did linear expansivity. Today we are going to do area and volume expansivity. All right. Christiana, how are you? Kebe, you're welcome. Christiana, you chatted me on WhatsApp. Yeah, like Esther, you're welcome. Thank you, Mr. Onyeka. I really appreciate. Christiana, did you chat me on WhatsApp? Please put down what we have. Kebe, don't forget to add her to the group, okay? So I can approve. Kebe, add her to the group after this class, so I can approve. All right. All right. Are we done with what we have on the board? All right. Are we done writing? Going to look at is area and volume expansivity. Is a continuation of yesterday's class. Now, if it comes to area, that means we are dealing with the length and the breadth, okay? Area expansivity, the symbol is what? Beta. Remember, linear expansivity, the symbol is what? Yes, the symbol is alpha for linear expansivity. But for area expansivity, you're going to use what? Beta as the symbol. Now, it's defined as the increase in area per unit area per degree rise in temperature. Let me go again. The area expansivity is defined as the increase in area per unit area per degree rise in temperature. That means beta, which happens to be area expansivity, is equals what? Increase in area divided by original area multiplied by temperature rise. Okay. Now the way I explained that of linear expansivity is applicable here. Now, what do I explain? That if the area of an object is increased, or before it was increased, we already have the original area before heating. Once heat is applied to a particular solid, it's going to expand. Now, if they expand by the length and the breadth, it becomes area expansivity. Now, the initial or the original area of the object before being heated is said to be what? A1. Now, after heating, it's going to expand, increase. Now, for you to be able to find the difference between these areas or these values, you're going to say A2 minus what? A1 to get the increase in the area. Because certainly, once heat is applied to an object, there must be an expansion, which causes an increase in size. Is that formula? You're going to have what? A2 minus A1 all over A1 bracket theta 2 minus theta 1. Okay? Now, what does this A1 stand for? A1 stands for original area, while A2 is new area. Theta 1 is initial temperature, while theta 2 is what? Final temperature. Now, there is something you must note. You must note that the area expansivity beta can never be given to you in any question rather. Can never be given to you in a question. Rather, there's a relationship between area expansivity and what? Linear expansivity. So beta is equals to 2 alpha. beta is equals to 2 alpha. Now if you have alpha, just multiply by 2. Whatever thing you have becomes your what? Beta, which is which is area expansivity. Is that clear? Now this is only when you're asked to find the area expansivity. I'm going to explain the new area and the increase in area. Still the same way as what you saw in linear expansivity. We are only changing the symbols from L to what? To A. All right, put it down. All right, are we done writing? Are we done writing? Like Esther, are we done writing? All right. All right. Put down what you have on the board. Let's explain. Tinyere mo, hi, you're welcome. Thank you for coming. Thank you for stopping by. All right. Are we done with what you have on the board? All right. So I want to explain this area expansivity further. Now, the only difference between this is that we're considering area. That of length is still the same thing, the same way of solving. Every derivation is the same. Okay. So if they ask to find the area expansivity, now the symbol for the area expansivity is beta, and the beta is equals to A2 minus A1 all over what? A1 bracket theta 2 minus theta 1. Okay. Now this theta 2 minus theta 1 is difference in temperature. If you are given temperature rise, you are going to use theta without, because we have just one single temperature, and that is our temperature rise. Now, if you're asked to find the new area is just like the way we solve for linear expansivity, making A2 the subject from this formula, and the formula becomes A2 equals A1 bracket 1 plus theta beta. I remember that when I was solving yesterday, and I told you that when you get to this point, there must be a multiplication sign connecting the area and the what? Connecting the temperature and the area expansivity. Okay, so you don't need to add before you multiply. So the first thing is to do what? Multiply this before you add whatever thing you have to 1. Now, the next one is for you to get the increase in area. It can be called increase in area, change in area, expansion in the area, or safety gap in the area. So it's still the same thing. And the formula is A2 minus A1 equals A1 theta beta. Is that clear? To 2 alpha. So if you are given an alpha, which is expansivity, just multiply by 2. Whatever thing you have becomes your beta. Is that clear? All right. All right, put it down. Let's solve. All right, you don't need to see the homework. Okay, I will send it to you on WhatsApp. All right, are we done writing? Do we understand? Is it well understood? Esther, community post, that is where I used to post the assignment. Okay, you go to my channel, you're going to, you search for community. Once you open my channel page, you're going to see community. When you go there, you're going to see assignment on the topic you are being taught. So just copy it and send your answer back when you are done solving. Okay, yes, that's what I mean by that. That's why I'll be posting your assignment, that is on community post. Okay, all right. Please, are we done writing? Prevail, you're just coming. Christian, I said I should throw my light up. I should explain further. I say that the way we solve for linear expansion similar to that of area expansivity. Now the only difference between linear and area is just because you are considering the length and the breadth of a solid when it is being heated. Okay, so the same formula we apply to linear expansivity, the same mode of solving is still applied to this area expansivity. Is that clear? Now if you're asked to find area expansivity, the formula becomes a2 minus a1 all over a1 bracket theta. Now remember in my linear expansivity, so that the symbol is alpha. If you're asked to find the linear expansivity is equals to L2 minus L1 all over L1 theta. Okay, let me say L theta 2 minus theta 1. Okay, it is similar to this. Why do I have L here and here I have A? Now this is because I'm dealing with the length, that is linear expansivity, linear expansion. You know, we have a solid has length, breadth, and what? Height. When the increase or the expansion is observed only by the length, it is tagged as expansivity. But when the expansion increase both the length and the breadth, it is tagged as what? Area expansivity, which is noted as beta. Now, when the expansion increases both the length, breadth, and the height, it is tagged as what? Volume expansivity. Is that clear? But we are using the same method, the same procedure, the same formula to solve. The only difference is this: when we have L for linear, we are talking about area expansivity, replacing it with what? A, right? Yesterday, we were able to solve 3 different problems on linear expansivity. We solve for linear expansivity, we solve for new length and the increase in length. So the same way we solved it, we applied it. That is the same way we're going to solve for what? Area expansivity. Is that clear? Now this one is increase in area. Increase in area is something as change in area, expansion in the area, safety gap in the area. All right, and the formula becomes a2 minus a1 is equals to a1 theta what? Alpha. And I said this theta you have is if you have a temperature rise given. You do not have 2 different temperatures, so you don't need to subtract to get your temperature rise. Is that clear? All right. Christiana, is that cleared? All right. So let's go into volume expansivity so we can solve problem. All right, copy what you have on the board. Let me explain quickly. All right, so let me explain. Volume expansivity, the symbol is what? Gamma. Remember, for linear expansivity, have alpha. For linear expansivity, have beta. Then this volume expansivity will have what? Gamma. So these are their symbols. Now, defined as the increase in volume per unit volume per degree rise in temperature. The same definition we have for area and for linear. All right, so gamma is equals to increase in volume all over original volume multiplied by temperature rise. Now, what am I trying to say? I'm trying to say that gamma is equals to V2 minus V1 divided by V1 bracket theta 2 minus theta 1. Is that clear? The same way we apply for linear expansivity is applicable here. All right. Now we can be asked to find the new volume simply by making V2 the subject. The same way we generate the new new for linear expansivity is what we are using for this one. That is V2 is equals to V1 bracket 1 plus theta gamma. Is that clear? All right. If you are asked to find the increase in volume, the same way by making this the subject, because this is the increase in the volume or the change in volume or the expansion in the volume. So we call V2 minus V1 is equals to V1 theta what? Gamma. And don't forget that there is a relationship connecting the linear expansivity and what? Volume expansivity. So V is equals to 3 what? Alpha. Okay, let me say gamma is equals to 3 alpha. So gamma will not be given in a question, but they're going to give you linear expansivity. So I'm going to multiply by 3 to get what? Volume expansivity. Is that clear? Right. David, you're welcome. We're late today. What happened? Should we proceed? Put it down, please. Let's proceed. Are we done? Can we proceed? David, are you done writing? So let's proceed to solving. Let's solve examples of what you just explained. All right, so let's solve. Let's solve problem. All right, copy the question, let's solve. And please be fast. All right, are we done writing? Are we done writing? So let's solve together, please. We don't have much time. All right, let's solve. A solid material of volume 100 centimeter cube is heated through a temperature difference of 40 degrees Celsius. Calculate the increase in the volume of the material if its linear expansivity is 2.0 times 10 raised to power minus 6 per Kelvin. Let me go again. A solid material of volume 100 centimeter cube is heated through a temperature difference of 40 degrees Celsius. Calculate the increase in the volume of the material if its linear expansivity is 2.0 times 10 raised to power minus 6 per Kelvin. Now, before I proceed, there is this thing I want you to know, that area expansivity is otherwise known as cubic, right? No, it's otherwise known as superficial. Sorry. Superficial expansivity. If they don't call it area expansivity, they call it superficial expansivity. Whereas expansivity is known as what? Cubic expansivity. Do you understand? So you must know these things. If they say superficial, calculate the superficial expansivity, calculate the area expansivity. If they say you should calculate the cubic expansivity, it has to calculate what? The volume expansivity. Is that clear? All right, let's continue with our solving. All right. Now, from the question, we are given a solid material volume 100 centimeter cube. That is my original volume. So, before it's been heated. Now, the V1 is equal to 100 centimeter what? Cube. 100 centimeter cube is heated through a temperature difference of 40 degrees Celsius. So my theta, which is temperature difference, is given as 40 degrees Celsius. All right, calculate the increase in the volume. The increase in the volume, remember, it is what? V2 minus what? V1. That is what you are looking for because that is the increase in the volume. If linear expansivity is, that is alpha is given as 2.0 times 10 raised to the power of what? Minus 6 per Kelvin. Right? Now I told you that if you are looking for anything in under volume expansivity, that gamma will not be given. They are going to give you alpha, and there's a relationship connecting alpha and gamma, that gamma is equals to 3 what? Alpha. So by the time you multiply this by 3, whatever thing we have becomes our volume expansivity. That is, this is 3 times 2 times 10 raised to the power minus 6, and the answer becomes 6 times 10 raised to the power minus 6 what? Per Kelvin. Is that clear? So this value is for gamma, which is volume expansivity. Now, for us to solve, what we are going to do is to remember our formula. That our formula is what? For us to get the increase in the volume, V2 minus V1 is equals to V1 theta what? Gamma. It's as simple as that. You can still use the other method of finding the new volume, then subtract from the original volume. It will still give you the same answer as using this one straight. So with that being said, so we now move that our new volume is 100 multiplied by theta, which is 40, then multiplied by gamma, which is what? 6 times 10 raised to the power of what? Minus 6. Okay, so we can use our calculator to do that to see what our answer will be. This is 100 multiplied by 40 multiplied by 6 exponent minus 6. Now what do we have? My answer becomes 0.024 centimeter cube. Is that clear? So my increase in the volume is equals to 0.024 centimeter cube. I hope that is clear. All right, put it down. All right, please put down what you have done. Do we understand? Do we have question? Should we proceed, please? I need a response. Okay. Esther, I said you didn't get it. Yes. Christian, I'm going to leave your answer like that, okay? But that is just the answer. Esther, let me run through and explain again because I want to solve like 2, 3, 4 examples. It will help you to understand better. Okay? This one I asked to calculate the increase in the volume, and the formula for increase in the volume is V1 theta gamma. Like I said, that the gamma will not be given in a question, but gamma is equals to 3 alpha. By the time you multiply by 3, whatever thing you have becomes your answer. That is for your gamma. Okay? All right, you can still convert it to standard form. It's fine. This one too is correct. You can leave it this way. You can leave it in standard form. You're still correct. Okay? Yes. Christian, you're still correct. So, Esther, let's solve more problems to understand better. All right, so can you put down this question? Let's see how we can solve it together. Christina, you're not done. Okay, so sorry. So you can watch it after now, okay? You can complete your note. So each time when I ask question, try to respond immediately. Okay, so that I know that we are working together. I didn't see your response on time, so sorry. All right, put down the question you have on the board. All right, are we done? Let's proceed. If you are just joining, give it a thumbs up, okay? Give it a thumbs up and make sure you subscribe to this channel. Are we done? All right, let's solve. The linear expansivity of brass is 2 times 10 raised to power minus 5 per Kelvin. Let me go again. The linear expansivity of brass is 2 times 10 raised to minus 5 per Kelvin. That is alpha. If the volume of a piece of brass is 15.00 centimeter cube, that is V1 at 0 degrees Celsius, that is temperature 1. What is the volume at 100 degrees Celsius? Now, for us to be able to solve this question, we must state our parameters by saying that alpha is equals to 2 times 10 raised to power minus 5 per Kelvin. Is that clear? All right. Now the volume given becomes our V1. Our V1 is 15.00 centimeter cube, right? At 0 degrees Celsius. So theta 1 is 0 degrees Celsius. What is the volume at 100 degrees Celsius? So we are looking for what? V2, which is what we are looking for. And the final temperature becomes what? That is theta 2, given as 100 degrees Celsius. Is that clear? All right. So for us to be able to solve this, the first thing we are going to do is to find our gamma, because we are looking for what? Volume increase in the new volume, okay? So remember that gamma is equals to 3 what? Alpha. Since gamma is equals to 3 alpha, and we are given linear expansivity, what we are going to do is just multiply by 3. So gamma is equals to 3 times 2 times 10 raised to power minus 5. Okay? Now it's going to give us 6 times 10 raised to power minus 5 per Kelvin. Right? Okay, so if you do that, you can also find our difference in temperature or temperature rise. That is theta is equals to theta 2 minus theta 1, right? So it's going to give me theta is equals to 100 minus 0, and my theta becomes 100 degrees Celsius. All right? Now the next step to take is to state our formula, and because we're looking for new volume, our formula becomes V2 is equals to V1 bracket 1 plus theta gamma. Is that clear? So you just want to substitute into what we have, and we see our answer smiling. Now our V1, my V1 is 15 brackets, I bring down 1, right? Now plus what's my theta? My theta is what? 100, then multiply by what's my alpha, my gamma? My gamma is 6 times 10 raised to power minus 5 per Kelvin. So I will say 6 times 10 raised to power minus 5. Is that clear? Now the next thing to do is to do what? Remember that there is a multiplication sign connecting the theta and the gamma. So I have to. So my V2 is equals to 15 bracket 1 plus If I multiply this out, I'm going to have 6 times 10 raised to the power of minus 3, right? That is multiply 100 by this. It's going to give me that. And the next thing I'm going to do is to add 1 to it. So V2 is equals to 15 bracket. When you add 1, you're going to have 1.006. Okay? Now the next step is now to open the bracket by multiplying this by 15. Now the answer will give us, let's say 15 multiplied by multiplied by 1.006. So my answer becomes 15.09 centimeter cube. And this is my new volume. Is that clear? All right, put it down. Please, do we understand? Put it down. Princess Madabuchi. What's your name, please? Is that your name? This is the first time you're coming to this class. All right, please, do we understand? Christine, I say you don't understand. Okay, let me explain again. All right. Now, when you're looking at the linear expansivity of brass, with the question, it is given as what? 2 times 10 raised to the minus 5 per Kelvin. If the volume of a piece of brass is 15.00 centimeter cube at 0 degrees Celsius. When you say at 0 degrees Celsius, this brass has not been heated, so this becomes the original volume. What is the volume at 100 degrees Celsius? That means at 100 degrees Celsius, temperature has been increased. So you're looking for the new volume. So the first step to take is to state the parameters given, which is alpha is equals to 2 times 10 raised to the minus 5 per Kelvin. Is that clear? Now, my first volume, which is V1, is what? 15.00 centimeter cube. Then my theta 1 is what? 0 degrees Celsius. That is what it is given here. And my theta 2 is 100 degrees Celsius. And I'm asked to find the new volume. Now, before you solve for the new volume, you don't even have the gamma, sorry, you don't even have the volume expansivity, which is what? Gamma, right? So what you are going to do is to say, from our formula, gamma is equals to 3 what? Alpha. Relationship connecting linear and volume expansivity. So we're going to multiply by 3 to get our volume expansivity. All right, so we say gamma is equals to 3 times 2 times 10 raised to the power minus 5, and they gave us 6 times 10 raised to the power minus 5 per Kelvin. Okay? Now, for us to get the difference in the temperature, that is temperature rise, we're going to say theta is equals to, because we have two different temperatures, theta 2 minus theta 1, right? And we got what? 100 degrees Celsius. Now, from our formula, V2 is equals to V1 bracket 1 plus theta gamma, right? Now, what do I mean by that? My V1 is equals to 15 bracket 1 plus, what's my theta? My theta is gotten to be 100 multiplied by, my gamma is gotten to be what? 6 times 10 raised to the power minus 5. Is that clear? All right. Now, we substitute in what we have, and I told you before that there is a multiplication sign connecting. What we are going to do is to multiply them together before we add what? 1. If not, your answer will be wrong. If you say 1 plus 100 before you multiply, your answer will be wrong. So to be on the safe side, multiply these two together before you add what? 1. So we have V2 is equals to, bring out our 15 bracket 1 plus 6 times 10 raised to the power minus 3, right? Now, if you multiply it, you're going to have 6 times 10 raised to the power minus 3, right? Okay, so by the time we add this to 1, we're going to have 1.006. All right, so we multiply this by this, the answer becomes 15.0 what? 9 centimeter cube. So this is the new volume that we are looking for. Is that okay? All right. Christiana, do you understand better now? Christiana, are you cleared? Robinson, maybe you have to watch the video after the class, okay? To be online after the class. So I can go to another thing. I've taken too much time on this. Actually, I want to solve another one for you before I give you classwork. All right, put this one off together. All right, are we done? Please, are we done? Are we done? Are we done? Nobody's responding. Kerry, are we done? Prevail done. Christiana done. Robinson done. Aleke, Esther, Princess, are we here? All right, so let's solve this problem. A solid metal cube. One thing you must know about this question, once you hear cube, something will come to your mind because a cube, all the sides are equal. All right, a solid metal cube of sides 10 centimeter is heated from 10 degrees Celsius to 60 degrees Celsius. If the linear expansivity of the metal is 1.2 times 10 to the power of minus 5 per Kelvin, calculate the increase in its volume. Do we get it? Let me go again. A solid metal cube of side 10 centimeter is heated from 10 degrees Celsius to 60 degrees Celsius if the linear expansivity of the metal is 1.2 times 10 to the power minus 5 per Kelvin. Calculate the increase in its volume. Now, for us to be able to solve this, this is a cube and all the sides are equal, and they gave us one side of the cube, that is the length, which is given as 10 centimeter. Okay, now for us to get the volume of this cube, we say that volume is equal to L what? Power 3. That becomes my V1. Now this is the same thing as saying L times what? L. That is 10 times 10 times 10 to give us 1000 centimeter cube as the original volume. Now that is V1. The initial temperature is given as 10 degrees Celsius, while the final temperature θ2 is given as 60 degrees Celsius. Okay, now we are given alpha to be 1.2 times 10 raised to the power of minus 5 per Kelvin. Remember that gamma cannot be given, or is not given in this question, but gamma is equals to 3 what? 3 alpha. Now, we are going to substitute to get the value of gamma by saying that gamma is equals to 3 multiplied by 1.2 times 10 raised to the power of minus 5. Okay? Of which when you multiply, you are going to get 3.6 times 10 raised to the power of minus 5 per Kelvin. Right? Now, the question now is for us to find the increase in its volume. Is equals to θ2 minus θ1. That is 60 minus 10 to give me theta to be 50 degrees Celsius. For us to get the increase in its volume, we are going to use V2 minus V1 is equals to V1 theta what? Gamma. It's as simple as that. We can use this method to solve it. This is a short method. We can also find a new volume, then subtract from the original to still get the same thing as using this formula. All right. Now we say V2 minus V1 is equals to, my V1 is 1000 multiplied by my theta is 50 multiplied by my gamma is 3.6 times 10 raised to the power minus 5. Okay, now let's work it out with our calculator. You see what I have? I have 1000 multiplied by 50 multiplied by 3.6 exponent minus 5. Okay, so my answer becomes 1.8 centimeter cube. That is the increase in its volume. Is that clear? Right. All right, do we understand? Do we understand, please? Christina, Esther, Robinson. All right. Kewa, do we understand? All right, copy fast. Let me give you classwork for you to attempt. Are we done? So let's solve. All right, so look at this problem and see if you can attempt it. All right. Okay. done solving? Please send in your answers so we can end today's class. Send in your answers, please. Okay, where are you still there? Christina there, Esther, Robinson. Send in your answers. We'll soon conclude. All right, let me solve. The increase in the volume of 10 centimeter cube of mercury when the temperature increases by 100 degrees Celsius is 0.182 centimeter cube. What is the cubic expansivity of mercury? Now, in this question, we are given, which is V1, to be 10 centimeter cube, and the temperature rises by 100 degrees Celsius. Temperature rise is 100 degrees Celsius, that is theta, and that increase in volume is given as, that means we are given V2 minus V1 to be 0.182 centimeter cube. What are we looking for? We're looking for the cubic expansivity, which is what? Gamma. All right. Now this is just the parameters given. For us to get the gamma, gamma is equals to V2 minus V1 all over V1 theta. Right? Now from the question, we are given our increase in volume to be 0.182 all over, my initial volume is 10 multiplied by 100. Okay, so I'm going to have 0.182 over 1000. Now, by the time I divide, I'm going to have my cubic expansivity to be 1.82 times 10 to the power of what? Minus 4 per Kelvin. And this becomes our answer. Is that clear? Right. Christiana, I got 9.81. No? Check your answer again. That answer is not correct. Check it again. Check it again, okay? That answer is not correct. Please tell me where you don't understand. Tell me where you don't understand. All right, Christiana, the 10 centimeter cube is the original volume. Is the original volume of mercury given in the question. Madam Bushi, you understood what? You understand what I just solved? Okay, where are you still here? Okay, where are you still here? Kelvin, are you still here? All right, Christiana, do you understand better now? All right, Christiana said, how will you know the initial and final? Now, looking at this question now, the increase in the volume of 10 centimeter cube, they are just telling you about the increase in the volume, but they now went ahead to still tell you that that is the initial volume of this particular mercury before it was heated, right? That is the only way you can know that this is the original or the initial volume. Okay, now if you want to find the final volume, it can also be tagged as new volume. Is that clear? Christiana, do you understand what I just explained? Can also be tagged as new volume. Is that clear? All right. Christiana, do you understand? Christiana, is it clear now? All right. Kewe, are you still there? I want to end the class right now. I want to be sure everybody understood. I'll drop your assignment in the community post, so you can go to my community, my channel, and search for the assignment under this topic to solve. Is that clear? All right, we have come to the end of today's class. I'll see you next time in the next one. Don't forget to go to my community post and check for an assignment I'm going to drop right now under this topic. The more you solve, the more you understand physics better. See you next time in the next one. Bye for now. Princess, do you have my WhatsApp number? If you have my WhatsApp number, chat me now and tell me, Auntie, I am Princess. Christina, tell me, Auntie, I am Princess, and state your class. I am Princess SS1. Christina, I am Christina SS1. Let me just add you right now as soon as I end this class. Okay? So most times when I send message, people don't respond. So if you respond on the group, respond in the WhatsApp now. You can chat me on WhatsApp now and tell me you are so person, SS1. Just state your class. I'll know where I'm adding you. Exactly. All right. All right. Esther, you have seen the community post. As soon as I end this class, I'm going to send your assignment there so that I can go and do it. Is that clear? All right.